Hey everyone, welcome to AC Academy. Today we are going to focus on Algebra 1, Section 1.2.1, and this involves linear equations with two variables. So today we're going to be focusing on the two variables x and y. We're going to read a given statement and produce an equation from that. Okay, so let's begin. Let's look at question 1. Question 1 states, basketball fans can purchase tickets at $60 each for the lower deck, right? So let me write this out. Lower deck equals $60 each. And I recommend whenever you read questions that you go through and you try to highlight or you try to write down what you believe is important in the question. I know a lot of these tests that you're taking might be timed, and you don't want to have to reread the whole question. You could have these little bullet points, like over here, that tell you, oh, this is the summary of this question, so I don't have to keep going back through and rereading the question. All right? So let me start over. Basketball fans can purchase tickets at $60 each for the lower deck. For the same game, fans can purchase tickets in the upper deck for 75% of the cost of a ticket on the lower deck, right? So upper deck equals 75% of the cost of lower deck. And this is each, right, for each ticket. So write the inequality that represents all of the possible ticket combinations of the lower deck, which is represented by X, and then the upper deck, which is represented by Y. Okay? And total is no more than 800. So no more than is the same as less than or equal to, right? So he's an example. He's no more than 14 years old. That means he could be 14, but he could be anything underneath 14, right? So the total has to be less than or equal to $800, right? So let's formulate this equation. We know that these variables are going to represent the amount of tickets sold in their respective sections. So we know that the lower deck is X, and we know that the upper deck is Y. Okay? And we're looking for an equation that represents the total number of ticket combinations, right? So the equation looks something like this. The cost equals upper deck price, so upper price, times the amount of upper deck tickets sold, which is X, plus the lower price, the lower deck price, times the amount of I think I got that backwards. Sorry. I switched that up. The lower deck price times X, which is the amount of lower deck tickets sold, and then the upper deck price times the amount of upper deck tickets sold. Okay. So we know that this cost, and I even got this equal part wrong. This cost has to be less than or equal to $800, right? So let's write it here. 800, that's the total cost, has to be greater than or equal to the lower price. And what is the lower price, right? The question states that it's $60 each for the lower deck. So that's going to be 60 times the amount of lower deck tickets sold, which is X, plus, and then the upper deck price is 75% of the cost of a ticket on the lower deck. And we wrote that down here as well, right? And then so we know that the upper deck price will be 75% of the lower deck price, which is $60, times the amount of upper deck tickets sold. So looking at 75% of 60. Now, what is 75%, right? You can call that 0.75, as in 100% would be 1. 0.75 is the same as 3 over 4, right? Now let's multiply this out. 3 over 4 times 60 over 1, right? So we know this is going to be 45. I'm skipping some of the math, but ultimately that would be 180 over 4, which is equal to 45. So the equation that we ultimately get is 800 is greater than or equal to 60x plus 45y. And that is your equation for this question. Now, to reiterate, to go through, we read the question, we went through each of the things that we thought were important, wrote them down, and that was the lower deck ticket price, the upper deck ticket price, and the total amount that you cannot be greater than. You can be equal to it, but not greater than, right? And after that, we wrote down, what does this equation look like? What's it going to look like with all the variables and everything introduced? And you're going to get the cost is you'll have your inequality here. So whether it's the cost is less than, the cost is greater than, your lower ticket, your lower deck price times the amount of lower deck tickets sold. Add that to the upper deck price times the amount of upper deck tickets sold. We did some simplification, and then we got this equation. Okay, so next question. It's going to generally use the same approach. A teacher is at the store ordering pens and pencils for the school year. The teacher can spend no more than $50 total. So first thing we write down, cost is going to be less than or equal to $50. And we know that pens cost $3 each. 3 each. While pencils cost $2 each. Each. Write an inequality that best represents all the possible pen and pencil combinations for the teacher. Right? This one's pretty straightforward. We know the general equation is going to look like cost is, and you'll have your inequality here. So I'll put like an equal in parentheses here just to represent that that might not be equal. It could be less than or equal to, greater than or equal to, less than or greater than. And you'll have your pen cost times the amount of pens sold, which we're going to represent with X, and pencils we're going to represent with Y. These I just assigned randomly. This could honestly be N and Z. This could be E and, I don't know, some Greek letter. It doesn't matter. You were just having a variable that represents each unit purchased of one of the pens or pencils. So we'll have our pen cost. Pen is represented by X. So pen cost times the amount of pens sold added to your pencil cost times the amount of pencils sold. Okay. And then from there, it's pretty much plug and chug. So we have 50. And we want the cost to be less than or equal to 50. So 50 is going to be greater than or equal to the total cost. Again, we want the total cost to be less than or equal to $50. So we know that $50, this is just reading this statement backwards, is greater than or equal to the total cost. And we know the total cost, we have our value that we don't want to spend over here. And we have the equation of the total cost here, right? So we have 50 is greater than or equal to, your pen cost is going to be 3. The amount of pens sold is going to be X, plus pencils is going to be 2Y. Okay, and that is your equation there. So I think these two questions were pretty straightforward, but what I would recommend is I'd encourage you to create your own problems. So these problem statements are pretty pretty like plain. But if you were to create a problem, so creating one off the top of my head, you go to a shoe store and you have people on your team, on your sports team, that wear a size 8, and you have people that wear a size 10. Each size 8 costs $10, and each size 10 costs $15. You know, what's the possible? I don't know, how much does it cost if you want to spend less than $400 for your full athletic team? So like, how many players can you have, right, of each? So you can create your own questions and then work through them and just check your steps with what's here. And I think that's a way to improve in this subject. So again, if you have any questions or any input on how these lessons can improve, go ahead and put them in the comment section and I will get to them. But again, thanks for watching, and I'll see you in the next video.